Hey, welcome to another adventure in old code. Apparently there is something in my arrays folder that's big and called face. So let's have a look. This is the precursor. No, this is not. This is FaceGame. This is FaceGame, but it is better. Okay. Good guy won. So if you recall, many episodes ago, we did FaceGame. And that was a wonderful little program. If we run it here. This thing. Remember, I could move around, and the bad guy could move around. Yes, I'm inherently the good guy, I guess. And we couldn't, we go on to these, I think the good guy's trying to get the diamond. I don't know, whatever the case. But the inherent issue was, you can go back. This is an episode my brother and I did together. It was a fun episode. But we didn't have arrays. We couldn't use arrays. And so we only had like 10 obstacles, 1, 2, 3, 4, 5, 6, 7 obstacles, 2 guys and 1 diamond. And so that's 10 different sets of coordinates, which is already a lot of variables when you don't have coordinates. And so, yeah, there was just a limitation. And the checking, we had to check each one. So if you... yeah, so this is us checking if you've hit any of the obstacles or not. And it was just really gross because there were no arrays. Well, now there's arrays. And so I didn't realize that this is a better version of FaceGame. I would have done this one with my brother instead of FaceGame. So let's try it again. The first thing you notice, there are way more obstacles. And we can't walk into the obstacles. The good guy can't. I'm pressing a button. Here's the bad guy. He can't walk into the obstacles either. We can't go off the screen. So we're stuck. The obstacles and the walls, they actually work. All right. The other thing is, whereas before anyone could go to the diamond. So the bad guy really is trying to get to the diamond. So as the good guy, here I am, I'm going to try and go on the diamond. And I can't. So that is very interesting. Can the bad guy go on top of the good guy? Yes, he can, but that is how the good guy wins. So he never wants to do that. So that is a lot better than the original FaceGame. I'm very pleasantly surprised this exists. Okay, let's have a look at how I did this. So we've got a good end and a bad end. X and Y variables. There are 2 of them. 2 players. Very nice. Block. This is a 2-dimensional array. There are 50 arrays of 2 elements each. So these are going to be the coordinates of each obstacle. Oh. XFAC and YFAC. Okay, each character has an XFAC and YFAC, I guess. This is what I was scowling at. Diamond. It's a 2-dimensional array, but I'm only using 1 row. If you can think of a 2-dimensional array as a grid system, only having size 1 means you're only using 1 row of your available grid. And so you could have easily just used this as a regular 1-dimensional array, but I didn't. Okay. Left, right, down, and up. Press good, bad, and our random number generator, which adds +2 instead of +1. So this is actually, if we put in, say, 10, this is going to give us not a random number between 1 and 10. This is going to give us a random number between 2 and 11. I don't know what the point of that is. Okay, randomize the timer, clear the screen, set up our key presses as always. Oh, good and bad, which are strings here. They're going to actually house the character that we're putting on the screen. Awesome. So good is CHR string of 2. Oops. And as always, CHR string of 2 is the good face. Bad is CHR string of 1. So from here on, we can just, good is the good face and bad is the bad face. Okay, for each of the 50 obstacles, block A1 is a random number between 1 and 70. There are 70 columns on the screen. And block A2 is a random number between 1 and 18. Oh no, 2 and 18. 2 and 19. 2 and 19. And this is 2 to 71. And I think the reason I did this is because no matter what obstacle, where the obstacle is on screen, I don't ever want the obstacle to be on row 1 or column 1. Oh, whoops. Because that is the wall. No obstacles on the wall. So I just built that into my random number generator, which is fine. A little bit, the details are a bit hidden, but that's okay. All right, diamond 1, 1 and diamond 1, 2. Again, random numbers, same thing. Now, the interesting thing is the diamond could actually be given the same coordinate. Actually, any block and diamond could be given the same coordinate. So I'm not sure exactly what happens in that case because I don't do any checking. I guess we just hope that they don't land on the same block. All right. Okay, now we have this nice do loop. Oh, same equals 0. Okay, well this is the check in case some of them do collide. Okay, let's have a look. So same gets set to 0, and we're going to do this thing twice. Huh. Okay. Oh no, no. Oh, I see. This is a check for... No, okay, I'm sorry. I was correct before. We don't do any checking. We just hope the obstacles and the diamond are all on different spots. I mean, if 2 blocks are on the same spot, then you have 49 blocks instead of 50. Not a big deal. I can see a problem when the diamond gets to be put on a block. So hopefully we check for collision with the diamond before we check for collision with the blocks. But now that we've got all our random coordinates for our obstacles and the diamond, we got to place the guys. Now the guys, we don't want them to start on an obstacle or the diamond or on top of each other. So I think that's what we're doing here. So for each guy, choose a random coordinate, and then for each obstacle, make sure that we're not on the same place. Now this is nice. First, we're going to check the x-coordinate of the guy with all the x-coordinates of the obstacles. Only if it's on the same column will we check to see if it's on the same row. This is more efficient. The naive way to do is just to check if the x equals the x of an obstacle and the y equals the y of an obstacle. You'll be checking the x and the y of each obstacle against a guy. But you only have to check the row if the guy's in the same column. So that's nice. So if there is a collision, then same gets set to 1, and that's our flag saying something's wrong. And so it'll just keep doing this. If there are no collisions, same will never be 1, and that's why we're looping until same is 0. Because it starts off as 0, gets set to 1 if there's an issue, so we can loop until it's 0. If we get there when it's 0, everything is fine. Okay, so here we're going to print our... Okay, this prints the top wall, the north wall. 73 of these characters, these wall characters. And then for each row, we're going to print the west wall, 74 spaces, followed by the east wall. Why are we printing that? We're printing a single one there. What happens if I don't do that? Why is that missed? What? Huh? That's really weird. Why is it doing that? I cannot figure out why it's not... Oh, because we're not actually using a locate statement here. Whoops. We're not using a locate statement. Sorry, I thought we were. We're just keep on printing the wall characters on the north wall, all on the same line, and then just keep going. The bottom, the south wall gets a locate statement, but this one doesn't have a locate statement. So it's actually continuing on and just wrapping around. And somehow we missed that section of the wall, so that rather than try and figure out what the issue was, I just, oh, that one's missing. Let me just put it in there. Okay. All right. Then we are going to, okay, that prints the south wall. Then for each obstacle, let's just throw it up there. Now we start with the second one because the locate statement, when you're in text mode, requires you to do your column first, followed by your row first, followed by your column. So that's why we're doing 2. The X's and the Y's are backwards when you're using text. Not very intuitive, but that's why that's happening. Okay, then we locate Y1, X1 and print good. Locate Y2, X2 and print bad. Those prints our faces. And then locate the diamond and print the diamond, which is CHR string 4. Okay, awesome. So here is the game loop. Okay, these XFAC and YFAC for each player gets set to 0. I still don't know what's going on here. Oh, that's, oh, okay. Oh, yeah. Okay, there's 0. Then we wait for a key press. Now, if it was left, then we're going to, if it was L, R, U, or D, that's the good guy's moves. The good guy is moving. So regardless of whatever he pressed, he's going to be moving. So what we're going to do is we're going to erase him. So we're going to locate his coordinates and print a space. That's what that is. And then we're going to say XFAC of 1 equals -1. This is the number we're going to add to his X value. Okay, he's moving up, so XFAC is -1. If he hits right, oh, sorry, he's moving left. X-fac is -1. Right, X-fac is 1. Up, Y-fac is -1. Down, Y-fac is 1. Okay, awesome. And then the bad guy's arrow keys are A, D, W, and S. Same thing. So now that we've essentially erased the guy that gets moved, and that's kind of nice. I mean, if the bad guy moved, the good guy doesn't get erased. Okay, so now we've erased the guy that's moved, and now we're going to do our wall check, our bounce check. So we're going to just set X-fac and Y-fac to 0 if he would have bounced into a wall and he can't go anymore. So that's great. And then at this point, we don't know who moved. We just have these 4 values, 2 of them for two of them for the good guy, 2 of them for the bad guy. X-fac and Y-fac, we'll just add that to your position and everything's great. I'm not sure why I did XA plus X-fac, and here I did Y-fac plus Y, but addition is commutative, so it doesn't matter. Okay, then for each block, yeah, we also have to make sure. Okay, so regardless, you don't actually step onto the wall, but you do actually step onto a block, and if you are on a block, we back you out. So basically, if the blocks is on the same row as the good guy, and the block is on the same column as the good guy, then the good guy is going to have his position undone. It's just the opposite of up here. Here we added to give him his new position. Here we're subtracting. So, I mean, that's not... We could have checked for collision with each obstacle before I actually moved him, but I didn't. So this undoes the moving if you bounced into a block. Okay. And we got to check for the bad guy. So now we're going to check to see if the diamond is on top of the good guy. That's the X and Y ones. And if it is, we're going to bounce him back just like we did with the obstacles. The good guy can't actually go on the diamond. Okay, then we're going to print good and bad. And then we're going to loop until the good guy and bad guy are on the same coordinates. That's accomplished by that. Or, and you can see this condition is all inside another set of parentheses here. So that means this condition has to be true, or this condition has to be true. It gets a little tricky when you get ands and ors in the same thing. I'm not sure which one actually takes precedence, and nobody ever knows, so just play it safe. You can put parentheses around things you want to be calculated first. So loop, keep going until the bad guy and good guy are on the same place, or the bad guy is on top of the diamond. Okay, so if the good guy is on top of the bad guy, then go to good end. And that is a really boring message. If the bad guy is on top of the diamond, then go to bad end. Okay, bad guy won. And keep looping until you hit escape. That's it. So it's too bad that I forgot this existed. You can see he blinks when I hit down. I'm moving the bad guy down. He blinks because I'm capturing the input, erasing him, moving him in memory, realizing that it's part of a block. He's on top of a block, so I'm moving him back and then drawing him again. Whereas if I go up and I try and get to a wall, it still blinks because I'm moving him. No, I'm erasing him, trying to move him, figuring out I can't, and then putting him back again. So anyway, that is Face. Now if bad guy 1, oh, it's just one level, that's it. So there could have been a scoring system or something. Okay, escape. Huh, escape doesn't work. Oh no, CHR strength 13 is enter. What? Wait a second. How come that doesn't work? What am I looping until? Oh, this isn't part of the big loop. This just waits for keyboard input after the game is over. Now it's do looping until inky string is not equal to enter. Okay, that was Face. Yeah. Another program which demonstrates the power of arrays. Try having 50 obstacles without arrays. That would be awful. Okay, thanks for joining me in this adventure in old code. Have a nice day, and we will see you next time.